Advanced DFX Strategy and Supply Chain Paradigm Shift from Medical Device Development. Episode 3, MedDevice Supply Chain Paradigm Shift, Defining and Solving for Supply Chain Risk, utilizing MIDI's de-risk method of DFSC. Today we're speaking with Christopher Montalbano. He's the CEO of MIDI Medical Product Development. MIDI, of course, assists clients in conceptualizing and commercializing their medical devices. How are you doing today, Chris?
I'm doing well, Matt. Thanks for asking. I'm excited for today's podcast, where I will walk listeners through the challenges MIDI's development team faced during the COVID era and unveil the unique risk mitigation strategies we devised, approaches that are proving just as valuable amid the renewed supply chain uncertainty caused by global tariffs. These strategies are indispensable for sustaining our clients' financial viability and for safeguarding public health by ensuring uninterrupted access to vital medical device technologies.
Chris, I'm so glad the MIDI team is sharing this unique and critical knowledge with the medical community in this podcast. Thank you so much for that. Now, I would also like to introduce a guest speaker who's on today's podcast. His name is Pat Farrell. He's the sales manager at Advanced Assembly. Pat's company deploys rapid time-to-market methods and the fabrication of assembled printed circuit boards to the industry. Later on in the podcast, Pat's going to provide critical industry insight on how to be preemptive with the approach to your printed circuit board development, given this new world supply chain paradigm. Welcome to the podcast, Pat.
Thanks, Matt. It's my pleasure to be joining the MIDI podcast. Looking forward to providing insight on the methods Advanced Assembly recommends to their client base in order to mitigate supply chain risk in their PCB builds.
Chris, what's the best way to kind of walk through this subject?
Matt, first let's briefly touch on where MIDI's advanced DFSC strategies originate from, which we detailed in the previous podcast. DFSC is one of the components of DFX. DFX is sometimes referred to as design for excellence, and MIDI operationalizes the X in the DFX as a variable, meaning DFX addresses optimizing DFM, DFA, and many other, including DFSC, design for supply chain. So this is all operationalized under a concurrent engineering agile development approach as detailed in our ISO 13485 QMS, meaning quality management system. Now, let's discuss some sticky issues the medical device engineering and manufacturing industry has come across in the last 2 months, along with what caused them, in order to then identify advanced solutions mitigating risk, which we refer to as the supply chain paradigm shift, deploying advanced DFSC strategies.
That sounds like a plan, Chris. So please step us through this.
As everyone is well aware, global events have disrupted the supply of material and components, not only in the medical industry, but in most other industries too. These impacts cascade downward through the medical industry, starting at the raw material supply side, through to the manufacturing at a component and subassembly level, and finally through to the final assembly build in preparation for market launch. The electronic component industry has been especially hit hard as a result of these factors, along with compounding effects from rise in need for components at a consumer electronic level.
This certainly crystallizes the fact that these are certainly challenging times given the world state of events. What are ways to mitigate these manufacturing risks? Because I know the medical device development industry is real big on technical risk mitigation in their designs.
True, Matt. And it is now time to be equally strategic on the supply side too, which the balance of this podcast will focus on. These approaches will require a true integrated team approach from engineering through manufacturing, including the supply chain. Let me start to outline this supply chain paradigm shift. Now, more than ever, medical device manufacturers need to adopt a risk-conscious posture where lowering the cost to manufacture is still important, but no longer the key driver in the design. Taking on this posture will provide greater assurances that your company will at least have a product to sell, but it may be at a higher price. Being at a higher price, though, does not necessarily make you less competitive, since the entire global economy is under similar pressures with resulting cost and price escalations. Now, the historic model to operate under is JIT manufacturing, meaning just in time, with lean inventory management. While one of the benefits of such an approach, where suppliers deliver your manufacturing line materials as needed, was to reduce material overhead costs and create production line efficiencies. Note that a system like this is at high risk when key suppliers can no longer deliver in a timely manner or possibly not deliver at all. So these approaches did not require a company to keep a safety stock of key supplies or even finished goods on hand.
What do you recommend medical device manufacturers do in this instance to achieve supply chain resiliency?
Contingency planning needs to be woven into the very method of operating at a corporate level and be disseminated as this new strategic method of operation at an engineering, manufacturing, and supply level. Now, the benefits of JIT operations involving quality, flexibility, waste reduction are just too significant to forego. The conundrum, though, is how to enjoy the benefits of JIT while ensuring you have enough inventory just in case global supply chain issues persist. So let's look for some insight here. J&J solved this problem with a what I'll call quote unquote sell one, stock one inventory replenishment policy that was structured to replace any inventory it sold just in time as it sold it, rather than dip into your existing inventory stockpile. With this approach, you don't set aside your reserve stock, or you could call it safety stock, but instead commingle it with the rest of the stock, thereby continuously replenishing the inventory. To properly implement an approach like this, you first need to ensure that the inventory keeps turning and remains fresh and current. And second, the inventory should not be used to cover ordinary production unless approved at an executive level.
That's a very unique approach, which appears to give you the benefits of JIT while mitigating production risks. What are some other key ways to mitigate risk using MIDI's advanced DFSC strategic approach under this supply chain paradigm shift?
Another one is to move towards an increase in the number of suppliers you source from at a component level. So secondary sourcing was the standard. Now a move towards tertiary and quaternary components and supplier sourcing is needed. Of course, all the suppliers need to comply with the regulatory scrutiny of the medical market and your ISO 13485 QMS vendor onboarding process. Also, another way, geography mitigation is needed as related to where the suppliers are located. The computer chip shortage is a good example where many of the components were sourced from China. Geopolitics also comes into play with this type of mitigation. So by having a global supply chain in place, if issues arise like in Russia and Ukraine, you are not at the mercy of a supplier in an area that can no longer perform. Note that one such cloud-based tool which allows you to evaluate these types of conditions in your supply chain is offered by Resilink. Third, use of an independent distributor can be valued. A good example of this type of strategy is related to the components required to assemble a PCB in your device. So often the purchasing department will utilize traditional distribution channels, typically ODMs or franchise distributors. Although in today's challenging times, these suppliers often can't provide the components within the required time frame or can't obtain the components at all. In this instance, the additive use of a reputable independent distributor is key. These partners focus on tough issues such as this and also offer some other benefits, which include, for example, they utilize procurement intelligent platforms that act as like a quote unquote control tower, meaning cloud-based real-time monitoring data systems tied to their global supply chain connections, enabling faster and more informed preemptive decisions in response to component shortages. These independent distributors also keep in step examining the EOL or end of life on components. This, of course, is an existing known practice already deployed at many device manufacturers. Although, given the current focus on component shortages, manufacturers can be distracted from the growing wave of obsolescence that's coming. Additionally, these independent distributors deploy quality control methods involving a stringent testing and screening process to ensure quality and authenticity of the devices offered. One such independent distributor that focuses on difficult tasks like this is a company called Converge at Arrow.
Those are some great strategies, Chris. I was also curious how a medical device corporation can be preemptive when initiating a new medical device development effort, knowing that all these manufacturing challenges exist.
True. Well, tight coordination needs to be maintained between the engineering department and the manufacturing department from day one. At MIDI, with new medical device developments, we operate under an agile development methodology with rapid iterations, where at each iteration round, you should now plan on buying your components for the entire year's worth of production inventory, especially for electronic board level components and critical parts or assemblies that need to be acquired at a system level. By working in this manner, while each successive iteration may need some design changes, a substantial portion of the component inventory will already be en route, and additional orders can be placed for the select set of components which change during the next design iteration. So you have, in essence, bought 1 year's worth of risk mitigation, and during that year of production, you should be preemptively preparing for the next year's inventory order. Realize that at the corporate level, a robust ongoing demand forecast analysis program needs to be instituted to properly inform the engineering and manufacturing department on preemptive order quantities.
Those are some excellent strategies, Chris, which will help maintain the viability of production and financial health of the companies producing the medical devices. Now, since electronic component availability seems to be one of the biggest pain points for manufacturers these days, I was curious to hear more about the nuts and bolts, if you will, or I think maybe bits and bytes, of how an engineering department can be strategic with their printed circuit board designs. Pat, can you provide some insight on that?
Hi, Matt. Thanks again for having me join today. As you can imagine, this is a critical topic for advanced assembly, and we've been working closely with customers to keep projects moving forward despite the supply chain issues. When designing PCBs for medical products, we have two main recommendations. First, design in from the beginning dual footprints, or what we call flexible footprints. A flexible footprint is a stepped land pattern that our R&D team developed in partnership with one of our customers. This was originally designed in 2018 when the ceramic capacitors were in short supply. Basically, this technique takes a stepped footprint and gives assembly houses multiple options for part selection. For example, if you design in the multiple footprints on one pad, maybe you need an 0603 footprint, but if this footprint will accommodate an 0402 and an 0805, we have the flexibility when one size is out of stock, but others are available based on value and tolerance. Similarly, can be used for some ICs. I've even seen an SMT part and a through-hole pad overlapping, allowing us to use either technology. Second recommendation I have is to be open to substitutions and provide replacement options. This is probably the most important strategy for keeping your projects on time. If you can, be willing to substitute any part that matches fit, form, and functionality. At the very least, consider allowing part substitutions for passives. This strategy provides confidence that the main components are purchased as designed, but avoids all other issues associated with locating passives. I have many clients who provide additional approved manufacturer's part numbers on their bill of materials. This will speed up the sourcing and buying process.
Those design tips are really helpful, especially when engineers are just starting to design a PCB. But what happens when a design is complete, or perhaps it's a legacy design and the components needed are hard to find? How does your company source those hard to find parts?
That's a great question, Matt, and something we run into every day. You're correct. Sometimes a project might have a part that is hard to find. In those cases, we recommend planning early and letting your assembly partner do the work for you. Number one, stay ahead of the game. As soon as you have a bill of materials, send it to your PCB manufacturer with the initial BOM. We can identify obsolete parts, components with long lead times, large minimum order quantities, etc. Because most of our customers are in the prototype phase or low volume production, they may not be able to buy a year's worth of components just yet. However, as soon as designers know they need a hard-to-find part, we recommend buying it immediately. We started doing this for our customers and holding parts in inventory until their designs are ready to be built. Leverage our relationships. We work closely with top-tier manufacturers such as DigiKey, Mouser, Newark, and Arrow. In some cases, we have dedicated teams on site at these suppliers, which gives us proprietary access to available inventory. In addition to the direct manufacturers, several certified supply brokers specialize in sourcing hard-to-find or obsolete parts and components. As Chris mentioned earlier, you should expand the list of suppliers you look at. Sometimes brokers can help locate and purchase what you need. I would caution you, however, to be careful here. We fully vet every supplier we work with to make sure the components are not counterfeit.
Planning ahead and working with professionals sounds like it would really help. Are there other strategies you have found that help overcome the component shortage?
I tell customers all the time to be flexible and get creative. Number one, a first article service. This allows you to test a few boards to verify your design before a large volume is produced. Purchasing parts in smaller quantities is usually easier. Number two, partial builds. If you need a build of, let's say, 100 boards, maybe parts are only in stock today for 20 to 30 boards. Be open to building a partial now while your long lead items are on order. Number three, reclaim and repurpose parts from existing revisions. We've helped customers take components off older revision boards and reuse them for new projects. This takes some time and expertise, but can be an option. Number four, work on multiple projects at the same time. Anytime we quote a BOM and discover a longer lead time or end-of-life component, and you plan on that part to be used on other boards in the design stage, maybe we grab a larger quantity now and hold it in inventory.
Get creative. I like that. Now, I'd like to ask you about costs. We all know that prices are increasing across the board. Is there anything engineers can do to help keep their project costs down?
As you pointed out earlier, a shortage in raw materials such as copper is increasing board prices. Also, labor costs are increasing, as well as shipping. The good news is there's a lot of things an engineer can do to keep the cost down on manufacturing their medical-related PCBs. Number one, on the fabrication side, use in-stock laminates when possible. This allows a fabricator to take advantage of quantity buys and avoid expensive special orders, which could have lead times. Let experts review your design and stack-ups in order to make recommendations on standard laminates instead of exotic materials. Also, reduce the number of drill and lamination cycles when possible and use standard hole and trace and space sizes. This will improve yields also. Number two, on the assembly side, if your project timeline allows it, quote a longer lead time. This is usually less expensive and avoids rush charges. Number three, design for manufacturing and assembly. Once your design is complete, make sure to run your project through a DFM/DFA software. This is like spell check for your boards. We found that nearly every design has at least one error that can delay manufacturing. This free printed circuit board inspection process prevents costly delays, ultimately reducing the need for multiple revisions. One common issue we see is the call out for a specific component on the BOM, but the footprint on the board is different or not ideal for 100% connection. All these checks avoid holds and additional costs when the manufacturing starts.
Saving money is always helpful. In my experience, getting your project back quickly usually begins at the quoting stage. My final question for you is, what can an engineer do to avoid delays and streamline the quoting process?
The most important thing is to send complete data right from the start. Also, understanding your deadlines up front allows us to mix and match lead times between the fabrication and assembly to provide the best possible outcome. The common files required are bill of materials in Excel, including manufacturer's part numbers, descriptions, and reference designators, Gerber files in RS-274X format or ODB++. With using Gerber files, we would need your XYRS or pick and place file showing the X and Y rotation for all surface mount parts. Lastly, including fab and assembly drawings definitely helps if requirements are non-standard or additional processes are required. And lastly, communication is also critical at the quoting stage. I like to have a conversation from the start and fully understand your intent. When you want to place your order and when you need boards back in your hands. Innovations in the medical device industry require PCBs that are smaller, denser, and more complex. That means your designs are going to be complicated, and your PCB manufacturer will likely have some questions or need clarification while reviewing your files. Respond quickly to keep your project from going on hold and ensure your boards work correctly right out of the box. Your relationship with a CM or board supplier is critical to success, and together we can overcome the current supply chain issues.
Thank you, gentlemen, for providing your valued insight to the medical device development community in these challenging and difficult manufacturing times.
Thank you, Chris, and thank you, Matt, for allowing me to participate in MIDI's podcast, and I certainly hope this is very informative to all our listeners.
Thanks, Matt. Reflecting back to the COVID era, businesses in every sector confronted unprecedented challenges. For MIDI, that trial by fire in design, development, and manufacturing fortified our development DNA methodology, equipping it to anticipate and mitigate future disruptions, whether global tariffs, supply chain shocks, or other unforeseen obstacles, to safeguard our clients' medical device initiatives.
You have been listening to MIDI's Innovation Vault series on advanced DFX strategy and supply chain paradigm shift for medical device development with CEO of MIDI Medical Product Development, Chris Montalbano, and Sales Manager of Advanced Assembly, Pat Farrell. This podcast wraps up the series. If you have any questions or comments on today's podcast or would like to schedule a complimentary consultation with Chris about your business, you can reach him by phone at 1-631-467-8686 or email innovation@midipd.com. If you enjoyed this podcast content, please follow MIDI on social media to download informative industry-related white papers and industry-supporting material at www.midipd.com. That's MIDIPD.com.